Hey everyone, Mr. Newman here, and I'm just going to do a few examples of trig equations to expose you to a little bit more variety of tools and tricks when solving these equations. So let's look at these three problems right here. This first one, what I'm doing is I'm going to be factoring, and one other thing is that I need to mention is that all of the domain of these problems, we're going to look from 0 to 2 pi, because that's a common area to look. What's tricky about that is sometimes there's more than one correct solution. We need to list all of those that are correct between 0 and 2 pi. So let's get started. First thing I'm going to do is I'm going to get everything to one side so I can factor it. By factoring it, now I've got just secant of x. I've factored that, and I can set each of those factors equal to 0. When we solve for the left here, we get secant of x is -2, and that means that cosine, the reciprocal of secant, is equal to -1/2. So when we're looking at the unit circle, cosine is -1/2 when x equals 2 pi over 3. But it's also -1/2 when x equals 4 pi over 3. So you have to make sure to list both of those. On the other side of the equation, secant of x is equal to 1. And that means cosine of x is equal to the reciprocal. Well, the reciprocal of 1 is 1, so cosine of x equals 1. And that means x equals 0, because inverse cosine of 1 is 0. You notice right here we have only or equal to 0. We don't have or equal to 2 pi. So 2 pi would be a solution, but that's not in the domain of where we're searching for solutions. So x equals 0 is our only solution there. All those three are your solutions: 0, 2 pi over 3, and 4 pi over 3. All right, let's do this next one. First problem I see is that I have cosecant and I have cotangent. So I need to rewrite them all to be the same kind of trig function. Well, I know sine squared of x plus cosine squared of x is 1. And if I want to eliminate this cosecant squared, I need to somehow get cosecant squared in my equation up here on the right. So let's see here, cosecant is 1 over sine, so I'm going to divide both sides by sine. That way I have 1 over sine squared on the right, and I notice that cosecant squared is equal to 1 plus cotangent squared, which is great because I already have a cotangent. So let's replace that with 1 plus cotangent squared. Let's rearrange it so we can factor it. And again, we're going to factor here, and we get cotangent of x minus 1 and cotangent of x minus 1, which is great because then we only have to solve one of the equations. So cotangent of x minus 1 equals 0, cotangent of x equals 1, and my domain, I'm going to use the same domain, and this will, I'll give the domain for you on the quiz. If it doesn't say the domain, please raise your hand and ask. But this domain will be 0 to 2 pi again, and the reciprocal of cotangent is tangent, so the reciprocal of 1 is 1, and I find it easier to search for tangent of 1 than cotangent of 1, though they're equal. And that means that pi over 4 and 5 pi over 4 are our two solutions, because both of those are root 2 over 2 divided by root 2 over 2, or in the case of 5 pi over 4, it's a negative root 2 over 2 divided by negative root 2 over 2. All right, those are our solutions. Last problem here. Here I notice a tangent to the 4th power, and we have a secant. So we first need to get rid of that secant, then we'll figure out what to do with that tangent to the 4th power. Well, sine squared plus cosine squared is 1. Secant is 1 over cosine, so I'm going to divide both sides by cosine squared. And we notice that secant squared is equal to tangent squared plus 1, which is great because we already have tangent. So let's replace that with tangent squared of x plus 1. And now I'm going to line them all up. I'm going to combine like terms, and I'm going to put them all on one side of our equation. Now, notice that we do not have any tangents in tangent to the 3rd powers, so I can treat this like a quadratic, where our variable is tangent squared. So tangent squared of x minus 3 times tangent squared of x plus 1. If you're not sure why that factors or why that squares, the 4th becomes a squared, multiply these two binomials out, and you can see from the Punnett square where that came from. That would be good practice even if you understand but you struggled to see it. So I'm going to set each of those equal to 0. And on the left there, tangent squared of x equals 3, and tangent on the right, tangent squared of x equals -1. Well, let's take the left here. First thing you need to do is make sure when you square root, you do plus or minus. I'll be honest, I started this problem and I worked it through, and about 5 minutes later, I realized, oh, I'm missing some solutions, and I had to go back and fix it. So don't be like me, don't make the same mistake. Remember the plus or minus when you take the square root. So let's look at our unit circle. I always draw the unit circle to help me out with tangent, but y over x, in other words, sine over cosine, I want that to be root 3, so it's going to be root 3 over 2 divided by 1/2. That's root 3. There's one solution there. Oh, again, I'm looking for between 0 and 2 pi. The other solution, so pi over 3 is one solution. The other solution is going to be down there where it's a negative divided by negative, but the same, otherwise the same x and y. And that's going to be my other solution for tangent of x equals square root of 3. For tangent of x equals negative root 3, I'm going to do the same thing, but those are actually on the opposite side. So we have root 3 over 2 divided by negative 1/2. That's 2 pi over 3. And then negative root 3 over 2 divided by 1/2. And that is 5 pi over 3. So there are 4 solutions. Let's now tackle the right side. Can't forget tangent square root of x equals negative 1. Well, tangent square root of x equals negative 1, if you take the square root of both sides, you were looking at the square root of negative 1. And that means that there are no real solutions to that side of our equation. So we don't have any other solutions beyond that, no real solutions at least, and those are our 4 solutions. I believe that's it, so thank you very much for watching.